Pretty good. Welcome back. The day's going well so far, I hope, for everyone. I'll see if you nod. That's good. So the next 45 minutes or so, we're going to be looking at continuous delivery with containers, the good, the bad, and the ugly. So containers seem like a really promising thing. I'm sure many people have looked at Docker, Rocket, Kubernetes, all this good stuff. It just seems so tantalizingly simple, doesn't it? We carve up our application, we ship it in these nice-looking containers, all hunky-dory. The problem is, if your architecture or your continuous delivery processes are a bit of a tire fire, what actually happens is you get tire fire in a container. Yeah, this is not a good thing. And you can see, I don't know if you can see there, just at the bottom, the people there, that's what we call DevOps, yeah? That's why we're here today, yeah? We all know it, it's tricky, it seems so promising, but that part of this talk is going to be about my journey over the last 3 years or so using Docker, using Rocket, Kubernetes, Mesos as well. I've learned a bunch of lessons, my team and I made a bunch of mistakes, a bunch of successes as well. I'd like to share some of that with you, and hopefully you'll share some stuff back with me, which I can teach again later on, which would be good. So continuous delivery is a massive topic. Yeah, I don't know if anyone saw Gianluca's talk before. Great talk, and he kind of hinted at it as well. It's continuous integration, continuous delivery, continuous deployment. There's a lot going on there. So I'm going to say today I'm not going to focus on the business stuff. There's just not enough time. So things like value stream mapping, I've done that with clients before, and sometimes we've actually figured out that the continuous delivery pipeline was not the weak link in the chain. It was actually the business. Henk hinted at that in the keynote after lunch. So you do need to think about the bigger picture. Can your business successfully take an idea, through to actually coding it and producing it? But we are going to make the assumption in this talk that we're good with the business stuff. We're focusing on the continuous delivery pipeline. I think PaaS, things like Cloud Foundry, Deus, things like that, and serverless are super interesting. I really think they're getting to the point now of proper acceptance. PaaS has been around for a long time. It's done some great things. But now I think it's truly there. But I'm not going to talk about that today. I'm personally doing a lot of work with serverless at the moment. I really think serverless is very interesting. But this talk assumes you're all in on containers and building containers yourself. Yeah, that's the assumption for this talk. Not going to do any live coding. I've got a mini book out, thanks to Nginx for sponsoring that, with O'Reilly. I've got a few copies here, so for some questions at the end, I can give you a few copies. I've only got 10, unfortunately. It was all I could get in the suitcase. But the book goes into a lot more detail. There's a GitHub repo with a Jenkins setup, and it installs Ubuntu with some scripts and various bits and pieces, so you can try a lot of what I'm going to be talking about today, and I'll be deliberately skipping over some of the tech details. You can try it out when you get back to the office, courtesy of this. So hat tip to Nginx for doing this, for sponsoring me. The takeaways I'd like you to think about as we're going through the next 40 or so minutes are that with a continuous delivery pipeline, you need to push something down the pipeline, and that must be the same thing all the way. Now, that becomes a container image. Many of us in the Java world are used to building jars, things like that. In Ruby, perhaps it's not quite so straightforward because we're used to packaging artifacts, repos, and deploying files via something like Capistrano. It's a bit different depending on the language you use to code things. But you must create one image, push it down the pipeline, and test only that image. I'll talk about it more later, but I've seen some people building images in multiple places, and variation creeps in as you push it down the pipeline. Adding metadata to anything in a continuous delivery pipeline is really important, but with container images, it is essential, but it becomes challenging due to some of the technology I've found. And we must validate the container constraints. A lot of us talk about non-functional requirements. I think I like the term cross-functional requirements better, because I've seen many systems that were not functional due to non-functional requirements, yeah? So I prefer the term cross-functional. Things like performance, security, all this good stuff. Containers do alter the platform, the fabric a little bit. So we need to cultivate something that's referred to by Martin Thompson as mechanical sympathy, understanding the platform just enough so we get the most out of it. Now, if you identify as being a developer, I'm not saying you have to become a sysadmin. I'm mainly a developer, I'd say, but I've become a lot more operationally aware over the last 3-5 years because it gave me a lot of advantages for building systems that got the most out of the systems and worked relatively well, or worked very well, hopefully, for my clients. This is me. So I love getting involved in the Twitters. So at Daniel Bryant UK. The UK is important. Someone else stole the Daniel Bryant before I got there. Please do tweet at me. Happy to answer questions. My DMs are open as well, so you can just ping me messages. More than happy with that. I'm working as an independent technical consultant, and I also do consulting CTO work at a company called Specto Labs, and we specialize in microservice testing, products, and training. So come and chat to me about that. My background is very much Java, but I do Go, JavaScript these days, a bit of Python occasionally as well. I do a lot of leadership stuff, but I try and remain hands-on. I think as an architect, and I kind of see myself as an architect these days, it's really important to be aware of the business and the leadership, but still keep your hands on the code. I think that's super important. And I do really think, continuous delivery, super important. Technology and teams, the combination there. Henk, again, hinted in his keynote. Teams are super important. This talk is going to be focused more on the technology, but do not underestimate the team's journey as you move to embracing containers. Often with containers, you start embracing things like microservices, and many articles on the web will explain that can be a challenge to your organization, okay? One final thing I would say is, I'm sure many of you guessed now, I'm a native English speaker, and I do tend to talk quite fast. So if I go too fast, just hand signal or something. I did this talk in Freiburg earlier in the year, and the first slide, everyone went like that, so I won't be offended, yeah? I'll try my best. So continuous delivery. I'm assuming many of you, if not all of you, are happy with the term continuous delivery. Does that make sense? I see a sort of few nods. If you're not, this book is a fantastic jump-off. It is the classic kind of book from Jez and Dave. It's really about producing valuable and robust software in short cycles, optimizing for feedback. Learning is also super important. If we can shorten the feedback, we can do more learning. Yeah, no more big bang releases. I mean, some of the clients I do work with still have to, but in an ideal world, you'd be deploying as often as you like. Yeah. It's not necessarily continuous deployment. Again, Gianluca talked about this a little bit. There is a big discussion around what is continuous delivery versus deployment, but in my world, continuous delivery is the ability to deliver business value at any point, and the deployment part of it is we do it automatically. That's just my personal definition. I've had a few very interesting conversations at conferences where people have disagreed with that. But a lot of businesses are quite scared about having this automated roll of code into production. And with good reason, I think. Many of the financial companies I work with like to get humans checking things over, and totally fair. I hope this is not a controversial statement, but creation of a build pipeline is mandatory if you're doing continuous delivery. Yeah? And by build pipeline, I mean this kind of thing. Gianluca, again, showed it. Are people familiar with the sort of build pipeline in terms of, we're code in our machine, we're pushing it to something like GitHub, like SVN, that kind of thing. In the Java world, we often use something like Jenkins, Travis. We build stuff, we run unit tests, component integration tests. We might do some code quality analysis, some cyclomatic complexity, some linting, that kind of thing with something like SonarQube in the Java world. If we're happy, we push it to an artifact repository, Nexus, JFrog, something like that. And then we pull that artifact down, we do our testing in QA. If we're happy, we push it through to staging. We do some more realistic testing in staging. Often say the third parties we're integrating against in QA, we might mock them out. But in staging, we probably use something like a sandbox, something a bit more realistic. If we're happy with staging, we push it through to production. And please do not forget, continuous delivery does not end there. Observability is super, super important for the feedback loop. We need to observe business metrics and technical metrics to make sure we can get better over time. So I'm not going to talk lots about observability. It's a big topic. But don't forget, the continuous delivery is the whole thing, including looking at what we're deploying and feeding it back into the whole cycle when we go again. Does that make sense so far? Everyone happy with that? Cool. So the impact of containers on continuous delivery. And again, who if you wouldn't mind, a quick show of hands, who is played with Docker? Who sort of, don't have to be in production or whatever. Excellent. Who is running Docker in production, out of curiosity? That's pretty good. Excellent. Thanks. So about sort of for the camera, about 25% of the audience probably in production, more than probably 60, 70 are familiar. It is just a form of virtualization. Many of us going into the cloud used to hardware virtualization like Zen, that kind of thing, VMware, that's hardware level virtualization. Many of us in the Java space are used to the JVM, that's kind of application level virtualization, and containers are just OS level virtualization, kind of in the middle. Been around for a long time. Docker obviously popularized it, and they sort of put a nice API, a nice developer experience around using containers, and did some fantastic marketing. So hat tip to Docker for doing that. They were building on LXC, and they've since swapped out to use other technology, but they really brought this technology that Google and many others were using, they brought it to us, which I thought was really cool. Core things, control groups, namespaces, and root file systems. Don't need to know too much about those, but sort of for controlling resources, isolation, and again, isolation in terms of file system. Namespaces, process isolation, network isolation, that kind of thing. This will be interesting. We'll talk about control groups a little bit later as well. Fundamentally, it's a way to package and execute software. We're used now to building Docker images. We then package our artifact, package our application in a Docker image, and we run that as a Docker container. Yeah. The container image now becomes what I've called the single binary, the single thing that gets pushed down a pipeline. If you're from the Java space, you're probably used to pushing down a jar, pushing down a war. If you're used to Python, Ruby, JavaScript, you're used to pushing down a code repo. Now you're going to be pushing down a container image. This is a big difference. So how does the pipeline alter? This is the pipeline we looked at just a minute ago. If we chuck in some, and I'm going to be using Docker and containers like sort of the same way. It's clearly not. I've just got the most experience with Docker, so you'll see me talk a lot about Docker today, but it's the same with Rocket. I've used that a bunch as well. LXD, there's a couple of other technologies. Microsoft are doing great work. But when you see the Docker stuff, just think containers, okay? But the pipeline alters in these ways. Now, starting over this side, clearly our deployment fabric now is going to alter. We're going to be deploying deploying containers to something. Probably a Kubernetes, probably a Mesos, probably a ECS, this kind of thing. There's lots more things going on, so you need some kind of orchestrator or scheduler. That, in turn, impacts how we run testing now, because we want to run testing on a like live environment as possible. So it definitely impacts QA. And the way we build things, the way we pull that down onto QA for testing now is changing, because we're pulling down a single container image or multiple container images. We're no longer pulling down our jar or our repo of code. And that finally clearly has an impact here as to what we're doing in development. Does that make sense? So dev changes now because we've got to respect what we're doing in production. Clearly the way we build now is different because the container image is going to be pushed down our pipeline and tested. And then that impacts QA, and that obviously impacts production as well. So that's what I'm going to be talking about over the next sort of 30 minutes now, I guess. Right. So let's look at creating a pipeline for containers. So starting on the left here, we'll move across. You need to make your dev environment as like production as possible. That, again, doesn't really matter about containers. That's irrespective of containers. But with containers, definitely true. Where how you're developing locally, the environment you're creating should be as like production as possible. That way we get the least amount of surprise when we do finally deploy something. You must build and test containers locally. In all honesty, I'm doing a lot of Spring Boot work these days and also quite a bit of Go work. I often build and unit test and integration test as I've always done. Typically these days I'm using Gogland or JetBrains' IntelliJ for Java. I'm developing in my IDE. It's all good. Only when I want to do sort of component or process style testing do I then put the artifact into a container. So I personally haven't altered my development workflow that much when I'm doing normal sort of TDD and that kind of thing. But some people I know actually mount directories into Docker containers and run code continually in Docker. Mount a directory, write your code to that directory, continually run stuff in Docker. Kind of like many people use Vagrant for a very similar thing. HashiCorp Vagrant. You can do that as well. But you must perform at least the happy path tests when you're developing locally. You cannot expect to code completely on your laptop without touching containers, is my message. Yeah. A common question I've done this talk a few times, a common question I used to get is how, I'm running microservices. Now, I'm not going to talk too much about microservices here. Bunch of other talks on YouTube you can check out where I've done that, and many other great people have done that, and then Michael's done many talks on microservices as well. But it's worth mentioning here. So there's a great, classic Hacker News article, discussing should you be able to run your whole system in production. And someone argued that you're not doing microservices unless you can run your whole system, in development, unless you can run your whole system on your laptop, you are not doing microservices, which is a classic Hacker News kind of, discussion, Anyone who's worked on a very large system, like a government system, a financial system, you clearly cannot run everything on one laptop. These things require mainframes and a bunch of other things. It's just not possible. But it was a very interesting conversation looking at how people are working with microservices, how when they're coding locally, how do they interact with many other services? Because now with a microservice system, you're not typically working in isolation on your application. You're dependent on something else, and something else calls your application. So how do you work with that, even with containers? So I wrote about this a while ago. It tripped us up on a project in the UK for a company called Not on the High Street. So I did an article that very kindly, I worked with them for a year, learned a bunch of stuff. So that article, I put the links there. Feel free to have a look. It's a couple years old now, but it's relatively up to date with technologies. And there's also things now like DataWire's telepresence. We were just talking about this over breakfast, Michael, actually, but telepresence is really nice as a kind of I just got to mention, I do some advisory work for DataWire. I don't get any money per se for recommending them here, but it's a fantastic product that allows you to work locally if you're working with Kubernetes and connect to a remote cluster. So you can develop locally, and you can have a big cluster running in the cloud, which is quite nice. And it allows you to proxy things both ways. So you locally can inspect stuff going on in the cluster, and you can also deploy your application locally, maybe debug it, maybe, put some statistics on it, and you can run it against this remote cluster. So if you're using Kubernetes, that's definitely worth checking out. And this is from Spectre, where I'm working it as well. Both tools I'm going to mention here are open source, so you can download them, look at the code, no fee to play around with them. They're all open source and free. Hoverfly is an API simulation tool. So if you're working with, say, third-party APIs, and you can't have access to systems when you're developing to test, you can record or simulate traffic with a Hoverfly. If anyone's used Betamax, VCR, Mountebank, things WireMock, things like that, it's like that, a slightly different flavor. We actually created this as an open source tool. We found it really useful when we're building our products to effectively mock out all these APIs, and you can capture the traffic going between your service and the APIs with Hoverfly. You can inject failure. You can do kind of Chaos Monkey stuff because you can put in what's called middleware. So you can look at the responses going back and create deterministic failures. There's a JUnit plugin, there's a .NET plugin, Python plugin, these kind of things. So these are things I found useful because it was definitely a problem to me. I'm running my containers, microservices locally. I've suddenly got all these other things going on. And it's a whole other talking about managing dependencies. I think Mike from Netflix is going to talk a bit about that tonight. It's a tricky thing, but I found telepresence, the ability to work locally and sort of connect up to the cloud, super useful. And virtualizing APIs, making synthetic APIs, again, very useful from when I'm working locally. Back to the scheduled program. So we've talked about, you need to make your dev environment as like production as possible, given the caveats I've mentioned. You cannot pull every service down locally. What you must do is when you are developing in a container locally, use the same base image in production as when you're working locally, use the same image as you do in production. I've seen some people use different flavors of different flavors of Linux. So they're developing, say, on Ubuntu because they're familiar with Ubuntu, but then they deploy in say, CentOS because the company insists they must deploy in CentOS. And there's subtle things, particularly in the way, if people are familiar with AppArmor and SE Linux, that kind of thing, there's very subtle differences between distros. So be aware of this. If you're developing containers, find out what's going on in production. Maybe your company's only licensed to run Oracle Linux, SUSE, whatever. Make sure you're using the container with the same distro. I've been caught myself on this one. Dockerfile contents is super important. Super important. A Dockerfile, if people not familiar, it's effectively a manifest file that describes your Docker image. Describe what OS goes into it, and it describes what artifact that we're building is going into it. We're opening up ports to the world, and we're telling the system how to run our application there. This stuff is really important. Now, as a developer, suddenly I'm exposed to things like OS choice. Yeah, before as a developer, I didn't care about that. I didn't know about that. I ran Apple, Mac OS. I didn't need to know about that. Now I do. Configuration. This one's simple, but I've seen very complex configurations going on in Dockerfiles. How do I get my artifact in there, and what should the artifact look like? Yeah, and how do I expose ports? Massive security vulnerabilities here by just, and I've done it myself when I was more junior. You just think, oh, I'll make it easy. I'll open up loads of ports. That'll make it work. Yeah, please don't. It's very dangerous. I've learned my lesson on that one. Again, language-specific stuff. Do we run a JDK or a JRE? Do we run a development kit? It's got a larger attack surface, so probably shouldn't be doing that. Do we run a JRE? Probably should. And then do we run Oracle or OpenJDK? Yeah, so that's the open source version, and Oracle's built on top. Again, whatever you're running in production, you should be doing locally. There is actually Oracle Docker images. Many people don't know this, but Oracle have got a GitHub repo where they've got all their images for Java, OpenJDK, loads of their own products. And they've got their own Linux, actually. There's Oracle Linux, version 7, I think, now. So have a look. If you're actually, if you're running Oracle in production, you probably want to run the Oracle Linux and the Oracle Java when you're developing as well. Golang, you've got questions like, do you run a statically compiled binary in Scratch, or do you run something a bit heavier? And I'll look at that in a second. Python, now that you're running in an isolated container, do we need things like virtualenv? Do we need things like RBenv if you're looking at Ruby? These are all questions that for me and my team, when we first came into it, we were a bit naive with some of these things, 3 or so years ago. The fundamental thing is please talk to sysadmin people. Please talk to your operation team. Their knowledge is super invaluable. And too many times in my consulting work, I've seen people, developers, myself included, ignore operations, until the last minute. And then suddenly they find out all this stuff. Oh, we've got to use this version of the OS. We've got to deploy it this way. And suddenly it's like, project is massively set back. Get your operations people, get your ITsec team, your security team involved as early as possible in the move to containers. They will undoubtedly be scared, and I've seen it get better, but when I was doing it, say, 2 years ago, chatting to InfoSec teams in London, you mentioned containers and the room just shut down. We're not running containers. They're insecure. I read an article on Hacker News. They're insecure. And I was like, ugh. And it was quite a battle to convince people that everything has vulnerabilities. Zen, hypervisor, powers most of the cloud, and Amazon, it has vulnerabilities that have been found over the last few years. You've got to manage your risk appropriately, So I've seen some people do different test and production containers. So they have one, they do testing down the pipeline, and finally they build a production one at the end. I get it while they're doing it. People like to put, say, databases in the test container. They sort of pre-can data, and they load it all together. They put test tools in the container, things like that. But it's easy if you've got multiple containers to see configuration drift. So sorry, if you've got multiple images, it's very easy to see application drift. What you think you're deploying into production by building that image at the last minute is very different than what you've actually tested on, or subtly different, even worse. What I'm going to recommend is using what they call test sidecars instead. Now, Brendan Burns is doing some great work around patterns for these kind of things, and sidecars is one of the patterns. And effectively, that says you build this one container, but you have another container, a sidecar container, with all the other stuff you need. Test tools, Selenium, databases, whatever. You keep the one image pushing down the pipeline, but you attach other images doing other things, other containers, when you need to do other things. Keep the one image pure and use other images to drive tests and do things like that. Great blog post here by Alexei, and he talked about something called an on-test proposal. If you're familiar with on-build in Docker, it's an interesting proposal. I'll let you read it. I won't go into too much more detail because it's pretty Docker-specific. But there was a kind of an answer to this at the recent DockerCon a couple of months back. Docker now allows multi-stage builds. I'm not sure if anyone played with this at all, the multi-stage builds. I've only looked at it a little bit, but it's quite interesting. You can now effectively, this is a Golang example, but you can effectively have a builder image at the top. This is all one Docker file, builder image at the top. It's using sort of the Golang Docker image, you're compiling and so forth, and then this is the actual deployment image here effectively. This is saying from Alpine, so we're running Alpine, which is a very small, lightweight OS. And then we're doing a very simple package update, no cache, get some certificates. And then we're setting our root directory, and we're copying, and that says copy from builder. and this is Golang is builder, so this image is effectively builder, copy from builder the artifact we've built into our image. So we effectively go from a heavyweight OS, we do all our magic, and then we copy the artifact into a more lightweight. The final from is always the deployable unit here. So this is worth a look. I think it could be abused. I think people could put lots of stuff here, and if you're not careful, you could see drift again. What you actually start testing in here is is different from what you deploy here. But it's an interesting idea. It's kind of following things from like Travis and Worker and things like that. If you haven't seen it, I recommend having a look. It's quite interesting. So that concludes that section. So let's look now a little bit about sort of packaging and putting in a registry or a repository our images. So no surprises here. And again, Gianluca did a great job for me, so I'm going to kind of keep this one quite short. I like Jenkins. I use a bunch of other stuff as well, but Jenkins has been a firm friend for 10 plus years, I think now. The book goes into a lot more detail about how to build images. It's mostly plugins these days, to be honest. CloudBees, who are the commercial arm behind Docker, do fantastic work. So CloudBees have got really nice plugins in Jenkins. Sorry, I made a mistake there. CloudBees are the commercial arm behind Jenkins. So Jenkins open source, but CloudBees do enterprise version, things like that. And they've released a bunch of open source plugins for Jenkins that allow you to build containers and so forth. Real nice. Configure, typically in Java, I build my artifact as I've always done. Then within my job configuration, I now put that artifact in a Docker image. Nice and simple. I like using Docker Hub. I'll talk about some other alternatives in just a second. But now you need somewhere to store your Docker image. Yeah, you might have had somewhere before where you stored just, if you're using Python or Ruby, you might just be using GitHub as your kind of place you deploy off a branch. But you are going to need a registry to store your Docker containers now. I'll come back to that in just a second, but a couple of things I've learned. Metadata, I think, is really important. As we're pushing things down the pipeline, we need to know when they're built and what's happened to them as they go along the pipeline. This effectively is metadata. Yeah, got our artifact. We're adding data as it goes down the pipeline. So we can determine, again, very important, if you're using things like microservices, you've got lots of things running in production. You need to very easily be able to determine what is in production. And when you're looking at an individual thing, what is the metadata? Who built it? When was it deployed? How long has it been running? These kind of things. Super, super important. Dialing it back a little bit, it's really important to version your images, yeah? Because again, you're deploying into production, you're going to be deploying multiple versions of things. Be aware, nearly everyone falls over the latest tag in Docker. So you can tag things by, this is my repo name on Docker registry, Daniel Bryant UK, / I've got a test image, and there I'm using semver, semantic versioning, 2.4.1. You can just tag things, you just leave them or tag them as latest. Be aware, and there's a great blog post that goes into more detail here, but latest simply means the last build tag that ran without a specific tag version. So I've seen people, particularly when working in pipelines with multiple people, some people were tagging with versions and some weren't. And there was real confusion over what was latest. Because if you tag something with an actual version, it's not necessarily latest, which is really quite confusing. The blog post goes into more details. It's not my blog post. But this is something that catches a whole bunch of people. You think you're testing against something because it's the latest image, but it's not actually what you think it is. So don't use latest. Every time you build something, tag your image with a version. Yeah? And you will notice later on in my examples, I forget to include versions when I was hacking together the examples. So don't do what I do what I say. And I say, yeah. But it's really important to put versions on. Gareth Rushgrove, I'm sure people have heard of Gareth. If not, you might read his newsletter. He's behind the DevOps Weekly newsletter. Fantastic web newsletter. Once a week on Sunday, Gareth rounds up all the interesting articles from around the world on the internet. Gareth is a super interesting character. He really gets DevOps. So if you haven't subscribed to DevOps Weekly, that should be the first thing you do when you leave the room in a minute. But Gareth has done a lot of thinking, and he's talked at DockerCon a lot around metadata. And he's saying we should include these kind of things as metadata when we're deploying our applications. So things like your version, kind of obvious, semver 1.2.1, maybe the git char of what you've deployed, these kind of things, and things like build date, image name, vendor. What I think is equally important is as we're pushing something down the pipeline, as we're pushing our image down the pipeline, we need to look at things like QA metadata. Has it been quality controlled? Has it been security audited? Now, Docker, in their enterprise product, are doing some very interesting work around this, around signing images. So you can cryptographically sign an image, and you can only deploy if you've got, say, 2 signatures. And one of those signatures might be from a security test. One of those signatures might be from say, a code audit or something. And you can automatically sign the images, and only if they've got 2 signatures can they go into production. But that is, I believe it's only in the paid-for product. We need to do something else, if we're just using open source, yeah? So you can add labels at build time. This is pretty straightforward. Are people familiar with labels? It's adding sort of metadata to your Docker, to your image. When you've got a Docker file here, you can put a label on. You can do basically key values. Yeah, and it's namespaced, so there's a few namespaces that are reserved for Docker, for example. But you can put your own company name, just like you would a package name or a module name, and you can put some data here. Got to give a hat tip to microscaling systems, who are sadly no more. They've shut up shop now, but they've got a great makefile Liz and Ross have put together for making this easy for us. So if you've got a Docker image you're building, you can use make, and it will take the system date of your local machine, a bunch of other things, and it will basically build you a correct label block within your Docker file, which is really nice. You can do things automatically on Docker Hub. Ross has talked about this quite a bit as well. You can put a file in the hooks build directory of your repository, and the Docker, when you build it on the Docker registry, it will fill in data as well. So you can add data at build time. This is pretty well understood. And I think Michael, again, I'm shouting you out a lot, but I think you're involved in this one as well, Michael, aren't you? Yeah. Label schema's got some great stuff around being a bit more specific on how we define labels. Docker, I think, it's really cool to put the functionality in, but they didn't think too much about how it might be used or how we as developers should structure our data. So Michael and Liz and a few other people have got together and created some very interesting stuff to read here about how we should structure our metadata in the labels. So check it out. It's definitely worth reading. Adding labels at runtime can be done, but it's a little bit nuanced. So you can imagine we're now pushing our image down the pipeline, and we want to add metadata as it's going down. You can do this. You can do Docker run -d here, label. You can put a label on, so I'm just labeling it as front door Nginx, for example. And you can Docker commit, and that will commit the labels into the Docker file, the Docker image, I should say, into the Docker image. Not the Docker file, it will commit it into the Docker image. But that does create a new image, which kind of violates the thing I'm saying about we should only use single artifact. At the moment, it's not possible to update a running container, and it's talked about on GitHub, quite a bit. So that's something to think about, as in you can add metadata using labels, but it's not really quite there yet. So I think I've got on the next slide, the best solution is to use a registry with metadata support. So JFrog Artifactory, and I've been asked to say the frog is hugging the whale, very clearly there, frog hugging the whale. I was suspicious when I saw this at another conference, and I was like, I don't know, that looks a bit, but that's straight from JFrog, that's not me. JFrog Artifactory is really good, and Nexus as well. Anyone in the Java space familiar with Nexus? It now supports Docker images. So you can still push up your artifacts into these repositories, but you can treat them as Docker registries as well, which I think is really nice. The paid-for versions have got more functionality, but I've mainly used the open source ones, in all honesty. But you can add metadata using their API as the artifact goes down the pipeline. So no need to modify the artifact, you modify the metadata in the registry. So that's the best solution I found. Moving on a little bit to, how are we doing for time? To the sort of QA part of the talk now. There you go. So, I'm going to give you more thinking points really around this. The book goes into a bit more detail. A couple of things I think are really important is testing. One is, component testing down here. So this is a very simple architecture I put together for the book. The code's available online. Spring Boot, Drop Wizard applications. Real simple, real basic kind of e-commerce shop. My UI skills are limited, so the web UI is horrible. But very simple application. You obviously want to test individual components within your architecture. So here there's a shop front, there's a product catalog, and there's a stock manager here, So we want to test the product catalog. Then we'll want to test the system as a whole as well. The component testing, and the other one's got a few different names, but those are the two most important things we need to test. And with containers, this can change. So it's not fully realistic in terms of the way the book talks. Typically, you'd have something like an API gateway up the front, routing your traffic, doing a denial of service prevention, something like a WAF, a web application firewall. Nginx, take your pick, yeah. And obviously, you'd have databases behind there. What I'm going to talk about over the next couple of minutes does ignore some of these things, but you can scale them up and come and have a chat to me afterwards if you want to know more detail about making these things more robust. But I'm a big fan of keeping it simple. The first test I always do is just, can I deploy the thing? Does it work, yeah? Gianluca, the talk before me, talked a lot about Jenkins pipelines, which I was super happy because I'm still a big fan of Jenkins, as I mentioned. And Jenkins pipelines is a way to codify your pipelines as code. It used to be called Jenkins Workflows, I think, because I remember using Jenkins Workflows. It was a plugin. Now you can use it. It's baked into Jenkins. You can see here I'm creating a job effectively. My code here, I'll talk about some examples through in a minute, but you effectively say, I want to run a job on a node, and you can have multiple stages. Build, test, deploy, these kind of things. You can codify this, and you can put it in GitHub along with your code. So you can have a Jenkins file in each repo. Dockerfile, Jenkins file, and some plugins to load in the Jenkins file automatically and create the jobs. Very nice. Does this kind of thing. This is the old view. Gianluca showed us the new Jenkins view, which is Blue Ocean, which is really cool. So if you haven't looked at Blue Ocean, please do. It's a real nice sort of UI layup on this. But effectively, the stages you define in your Jenkins file, in your Jenkins pipelines, are shown here. So you get a real nice view as the code's building, and when it's built, things have gone wrong. You can see where in the pipeline things have gone wrong. All codified as well, which is nice. So this is one example I've used in the book. So you can effectively, if I ponder a hope, don't know how it will look at the back, but you can see I'm running something on a node. This is just running a single Docker image. Now, I've built my product catalog, I think it is, or shopfront in this case. I've built my shopfront previously. I'm using the CloudBees plugin to build my image. And then I'm using the Docker plugin. I'm saying pull down the image, run it with ports open. This is just a Groovy script. Groovy is what's used in pipelines. I've got a timeout here of 30 seconds, and I'm waiting, very simple shell script here, that's basically curling the localhost health endpoint of my service and grepping for the word up. You can do what you like there, basically, but it's quite simple. And that basically is a timeout of 30 seconds, and if it doesn't return true, that's a slight Jenkins fiddle you have to do there. If it doesn't return true in 30 seconds, the build will fail. The thing didn't run. The health health endpoint, didn't return that it was available. Really simple, really very easy to do, I think. Yeah, I've used this one a few times. If we're going to try and mix it up a little bit now, we're going to be load testing, say, or security testing the whole thing. A bit more black box style. We're now running multiple services, these kind of things. How does that differ a little bit? Well, it does. Multiple ways you can do, and depending on what you're running in production, you need to modify this step. So I'm going to use Docker Compose as a way of composing multiple containers, multiple services. If you were using Kubernetes, you'd want to be using Kubernetes, maybe Minikube, something like that. Whatever you're using here in production, you need to be using here as well. So please don't test something on Docker Compose and then deploy on Kubernetes. Because again, subtle differences, yeah, or not even that subtle sometimes. But you need some way of being able to compose your system or a chunk of your system, because sometimes you can't run the whole thing. You want to be able to run a chunk of your system and drive traffic through the front door. Yeah, I've done this again with Jenkins with pipelines, and I'm using a few more stages here. I'm doing some building at the top, build stage. Then you'll recognize this bit of the code. It's very similar. It's waiting for the health endpoint to return up. And then I'm doing some other tests here. And I don't know if anyone saw Christian's talk earlier on today, but I've used things like pen testing tools. Anything that you can deploy onto a box, you can run effectively here. So you can do, this is, again, a trivial example, but you can run other things. The whole system is now up. Use Docker Compose to spin it up, and I can run basic tests against the whole thing. This is a very simple way of doing it, but it's got me started, and then I've the team and I have often evolved the solutions to be a bit more complex, a bit more thorough. But this is a good way of very simply spinning up a few services, using Docker Compose in daemon mode, running a few tests, and then shutting it down at the end as well. I mentioned Christian's stuff. I didn't see Christian's talk this morning, but I've seen him at Java 1 last year. And things like testing non-functional requirements, like security, and Christian is very much an expert in that space, but testing these things, it's got to be done in the pipeline now. I think it only really became viable a year or two ago. Organizations like OWASP have been talking about this stuff for a long time, but some of the tooling wasn't quite there. I think it is now. So same with performance testing. I've done a whole bunch of work with JMeter in the past, and there's a great talk this morning I saw with demos of load testing. JMeter for some things can be really quite cumbersome. It's a very old tool. It's like 98, I think it was written in. Fantastic tool, but I've moved more towards Gatling. Gatling is a Scala-based DSL. You don't really have to know Scala, so whatever language you code in, you'll be fine. Very simple DSL for specifying testing against a website. URLs you're going to hit, number of users when you're doing load testing, how the users ramp up, how they interact with the site. It's very readable. You can give it to, say, a non-techie person. They'll be able to read how the test's going to work. I really like the DSL. Is very well designed. And you can run it in your pipeline. You can run it locally. And there's a commercial product, which I've used a few times, called Flood.io. And it actually takes your Gatling scripts and runs them on Amazon. You don't need to see any of that detail, but you just say to them, here is my Gatling script, run it on 1 million users spread over 10 boxes. And they'll spin up the Amazon boxes in the back end, and they'll start hammering your staging environment, those kind of things. So the reason I really like Gatling is, it's just a really nice DSL, but Flood allows me to run it at scale. And it's not crazy costly. It's reasonable. Security stuff, again, Christian's talks about this a lot more, but basics like find sec bugs is a tool to do vulnerability static scanning on your code. That, for me these days, is table stakes. You must be running vulnerability scanning on code. Black Duck are out there. Go and chat to Black Duck as well. They're awesome. Dependency checks, again, table stakes. Whatever you're using, Java, Ruby, Python, there's pretty much a plugin here that looks in the dependencies you're pulling into your project to see if there's any critical vulnerabilities. If you've actually got like an old logging library or something like that. This, you shouldn't deploy if you've got a dependency with a critical vulnerability because you're asking for trouble. You can put it in your pipeline, no problems, yeah? Things like BDD security are a wrapper around the ZAP, which is an automated penetration testing tool. So you can codify in a behavior-driven design style way of asserting security credentials, security properties, I should say. Arachnes are more as a JavaScript, more JavaScript-focused penetration testing tool. Very, very nice. It doesn't remove the need to do proper penetration testing, but it covers the basics. Yeah. Gauntlet and Service Spec, I will talk about them a little bit more later. They're more for if you're building infrastructure. They torture infrastructure is the idea. Docker Bench for security and Chorus Claire. Chorus Claire in particular is open source. They're container scanners. Yeah. So clearly you need to scan your code for vulnerabilities. Have I done something stupid with sessions? Have I brought in an old dependency with some vulnerabilities? But now we're deploying the image. We're packaging everything up to an image. Therefore, we need to scan the image because we might have brought in an old OS library with Heartbleed in, something like that, yeah? So these are things for me, you can put them all in a core OS, you can definitely put it in your pipeline. Bit of work required because it's open source stuff. But this for me, it's got to be done. We've got to start getting these NFR tests in our pipelines. It's very rare, very anecdotal experience. I work in Germany, I work in London, in the UK, but very rare I find people codifying this stuff. When it's done really well typically, but there's not a lot of people codifying this stuff. I'm really keen to see it done a bit more. If you're doing Docker in particular, there's a great gent called Aaron Gratifiore. He's done a bunch of talks. Google for them online. That's a Docker-specific security paper. I wrote it up. I think his DockerCon talk, and it was an amazing talk. He talks even faster than I do. The amount of information delivered in 1 hour was just insane, yeah. So I had to watch it back at half speed. But it was a really great talk. And if you Google for Aaron, Aaron is a real container security expert. And I think, we as developers don't need to be that level of expert, but I learned a bunch of stuff from his papers. So I highly recommend reading that if you're serious about container security. Delaying, so I often get pushback in my consultancy work, as I mentioned. I say to people, we need to get performance testing in day 1, day 2. We need to get security testing in day 1, day 2. And people like to say, because we're agile, we delay stuff to the last responsible moment. And this notion of last responsible moment is very powerful. It allows you to defer things until, if you didn't make a decision then, it would be irresponsible. Yeah, so the idea is you do just-in-time design, just-in-time security checking. But the newsflash for me is sometimes the last responsible moment is actually up front. Yeah? If I don't know how many people are going to be using the system, how can I architect for that? If I don't know how things are going to be exposed, how people are going to use the system, how can I make it secure? Yeah. It's really hard to push back to business people, but I've started doing it a lot more, because otherwise you get this kind of thing. Yeah? You end up fixing stuff fast rather than fixing it right. Yeah? And that one's a bit dangerous, I think, there. My experience, containers and microservices don't make this easier, because all of us are learning new things about containers. Your ops team are going to be super comfortable with VMs because they've been running Zen for years. They've been running VMware for years. Containers is scary. Microservice means you've got more things going on there now. Yeah? So definitely need to think about this stuff and get it in the pipeline as early as you can. Particularly performance testing, you can watch how your individual microservices are performing over time. That's fantastic, avoids a lot of problems. Getting security stuff in just gets people in the security mindset from day one. It's much easier to get people in the mindset of security from day one than it is day 100. Yeah, trust me, I've been there on that one. I talked a bit about mechanical sympathy. So out of curiosity in the audience, who would sort of identify as a Java developer? Who's on the JVM stack? It's about 20%, so not everyone. So I'll keep this one relatively short. But what I'm going to try and say is be aware when you're developing with containers, the properties, the fabric, alters underneath you compared to deploying on, say, bare metal. And we need to cultivate what's called mechanical sympathy. Whatever language you use, you need to understand how your language is going to interact with Docker. A couple of Java things. At the moment, it's still the case that when Java starts up, by default, it looks at the number of CPUs available on the box, and it takes half the RAM for the JVM. Yeah, that makes sense. In the Java world of yore, like Java spun up, it assumed, the JVM, spun up, and it assumed it owned the box. Back, when Java was created, that makes total sense. You were deploying a JVM on its own machine. Yeah, that kind of makes sense. These days, not so much. And unfortunately, Java, the JVM, isn't cgroup or task set aware. So the classic is it only sees the host number of CPUs. Yeah. So what you can do, we did this one time before. We had a box with 64 cores, and we carved that box up on Amazon. We carved the box up to run 64 Docker containers with one CPU each. Yeah, very lightweight process needed. The problem was the 64 JVMs spun up, and they all thought they had 64 cores. Yeah. Now they don't get access to the actual, the OS will stop them. But they make decisions based on, the JVM makes decisions based on the number of cores it thinks it has. And the fork join pool, bunch of other stuff, the way it garbage collects, are all based on what it thinks it has. But unfortunately, it's looking at the host. It's not looking at the C group, the container isolation. A bunch of other languages have similar issues as well. So you need to think about these things when you're running. You need to assert these properties in your build pipeline. Memory, same kind of thing. All too often, I see it now, and hands up, I did it myself when I first started working with Mesos, actually, is in Java, we have this notion of a heap space, your kind of working memory, effectively. And very familiar, a lot of Java developers get familiar with it very early on in their career, and they learn to set their, their heap space quite close to their memory space on their machines. So they often say, I've got a container, and I'm going to give it 2 gigs of memory. I'm going to run this container with 2 gigs of memory. So they give the heap 2 gigs of memory, yeah? The working space 2 gigs. The problem is, the JVM, for example, has an overhead itself of the process, and it requires some stuff, what's called metaspace. There's a bunch of other things. So whatever language you use, .NET is the same, don't you give all the RAM in a container to one thing. You need that sort of buffer. I've often found it's around 10, 20% you need as a kind of buffer over and above the actual heap space. So be really aware of these kind of things. Also be aware if you're running other stuff alongside your artifacts, you're running Java and a couple of other things as well, be aware that will take up memory, that will take up CPU, things like that. And there's some things around like thread stack size, which I've blogged about if people are kind of curious on that stuff. Final one on the mechanical sympathy thing is think about entropy. If you're doing cryptographic operations, which most applications do, so you're spinning up sessions, these kind of things, you will exhaust the entropy. So I'm using my microphone here. You will exhaust the entropy on a host. It's much easier to exhaust entropy on a virtualized box. Entropy is effectively the randomness, so mouse movements, keys, anything that the computer can use to generate randomness, because it needs to be seeded with randomness. When you're running on a server, that's often challenging because there's no mouse typically attached to a server. It often looks at network traffic coming in to try and generate randomness. But when you're carving up that server in the cloud with lots of Docker containers, all drawing on the entropy pool from dev random, it can actually end up blocking. So if you see things like session generation or cryptographic operations just jamming up, stopping, it can be, and you're running containers, this can be the source. I had an example with Spring Boot, where it was sometimes we were running Spring Boot apps on Amazon in Docker, and it would just spin up and it would just stop halfway through initialization. And we were super confused. We actually went in, we used JStack to break down what was going on, and we could see that every time the application froze, the stack trace froze on a cryptographic operation. Session generation, token generation, SSL stuff. And then we started reading around and we suddenly realized, oh my God, we're using up all this entropy. And when we tried to call out to dev random, or when Spring Boot called out to dev random, it blocked. So that was a big problem. So you can use things like dev urandom, but there's security implications for that. So just be aware of these things. And again, test these things in your pipeline. You need to do performance testing, load testing, soak testing. Like, the great talk earlier on again today about automated testing. But you need to run things, for a day or more sometimes to get these things to show up. Observability I've mentioned is core. I'm not going to talk about it too much, but who is it? I always forget the name. Is it Adam Turnbull, I think it is? Thanks, James Turnbull. Great book, Art of Monitoring. So if you're looking to learn more about observability and monitoring, James Turnbull's book is fantastic. There's a tweet of Bridget's I took out. But it's really important to get that feedback cycle going. Yeah, you need to monitor both from a business point of view and an operational point of view what's happening and feed it back into kind of your development processes. On InfoQ, there's a nice QA we did with a few sort of industry leaders around this kind of thing as well. So there, I'll put the link there. That's a great jumping off point if you're looking to understand how things change with containers and microservices. Nagios probably doesn't cut it anymore. Distributed logging is a thing now, or logging from multiple services. It's good to get sort of familiar with this stuff early on when you're building things. So there's a couple of things to think about. Observability is super important. Continuous delivery does not end just when you kind of deploy something. So that's pretty much wrapping up in the final few minutes now. Containers are not a silver bullet. Hopefully anyone attending a conference, you're all kind of self-selecting, you're keen to learn, you recognize these things. But I definitely see people in the industry that think containers are a silver bullet. Serverless is a silver bullet. Cassandra is a silver bullet. There are genuinely no silver bullets, and we've got to react accordingly with these things. Incorporate our learnings into the build pipeline. If you're looking to move to containers, people often ask me, should I go all in? Should I do a big project where I carve up the monolith and chuck it all in? It looks so tempting, doesn't it? Get everything perfectly shiny, build a new ship, put everything in containers. My general philosophy is start small, and go from there. I know that people often use this as a kind of derogatory image in container space, but for me, it's actually pretty good, A lot of us are working with big organizations. We've got a lot of challenges from the business or challenges from InfoSec. And if we go all in on a big ship, it's going to be much harder to get it validated, and we're going to delay our learnings till much later. So this kind of thing for me is really important. Build out a simple Jenkins pipeline. Show it to your InfoSec team. Show how you've got security scanning going on. They're going to love that kind of thing. It's going to be a discussion going on, which is what you want. People often ask me as well, so, this Kubernetes looks a bit complex, or Mesos, or whatever. Should I build my own container platform? And the answer is probably not, unless you're Pivotal, IBM, or Deis, You often need to build a bit of glue kind of components around platforms, but things like OpenShift these days, and Deis, OpenShift in particular, I'm a massive fan of OpenShift. They give you a lot of the workflow that you expect as a developer now. They give you kind of pipelines, combining it with Jenkins, these kind of things. You don't need to invest lots, I don't think, in building out your own platforms for containers. Whatever you do decide, and if you do decide to create a platform or some kind of glue, infrastructure glue, you're spinning up Amazon EC2 instances, deploying Kubernetes onto that kind of thing, that's great. Whatever you do, make sure the infrastructure code is also pushed through a pipeline. And you join the pipelines, the infrastructure and the dev ones up at some point as well. Keith's book awesome book. Keith from ThoughtWorks. This won't make you a Terraform or a CloudFormation expert, but it gives you everything you need to understand all the problems around building out infrastructure as code. Fantastic book. It's not very big. It's well readable. So do check it out. Whatever you're doing in terms of building a production platform for containers, codify it. Put it in code. Put it through its own pipeline. Final word of sort of advice, and I've seen this and I've kind of been guilty myself, is using containers does not obviate the need for good architectural practices. I've seen people try and hack up applications, chuck them in a pipeline, these kind of things. And it kind of, you get this sometimes, yeah? We crammed this monolith into a container and called it a microservice. I've seen the same thing, we chucked an API on top and we called it a microservice, these kind of things. Fundamentals, I mentioned about thinking about business is really important. And I would say this is Casey West, it's not my quote. Casey West, very interesting character from Google, does some great talks, so check out his talks. But don't forget your fundamentals, yeah? Before investing in continuous delivery, think about the business, think about the value stream, think about architecture. My talk today is very focused because that's what I wanted to do, but we are, as developers, operators, QA people, we are always operating in a bigger context, yeah? So do bear that in mind. This is pretty much the summary. I think I'm bang to time there. Continuous delivery, super, super important, yeah? The container image must be the single source of truth going down a pipeline now. Don't be tempted to rebuild the image as it goes along, yeah? I've done that. You can see drift happen all the time. Add metadata so you can track where things are going and when they're in production, what they are, and these kind of things. We need as developers to be aware more of the underlying mechanics. How does containers, how does cloud alter our experience of running things? Yeah? Develop mechanical sympathy and assert the properties in the pipeline. Test performance on a very small scale in the pipeline. Test security in the pipeline. And then arguably, as you go down the pipeline, you do bigger and bigger tests. Yeah? The tooling is definitely becoming stable. I've been doing this talk for quite a few months now, actually, and every day it gets better. When I first started doing container stuff, we had to build a lot of our own tooling. My team did a fantastic job, but they're much more technical than I am, but as in, it really was hard work. Now, really it's about applying the good practices of continuous delivery onto containers. Things like the vulnerability scanners are there now. Things like all the plugins for Jenkins are there. We just have to do a little bit of assembly, make sure we're thinking like good developers in terms of asserting all the properties in the pipeline, and we are good to go. Yeah, but we must make sure we do this kind of thing. I love reading. I did have before I changed job, I had a long commute in the UK where I was commuting a couple hours a day, so I've hammered the books. But these are some of the references over the last 3 years that I've read that have really helped me in my journey. So the slide deck, I'll put it online later so you can grab these things. But if you're building a container system with some microservice stuff, got to really shout out Susan's book. This is a fantastic book for thinking about architectural and operational properties and using things like checklists to assert or to validate, I guess, that we're doing certain things. Really valuable. Excuse me. Eberhard's book's fantastic as well. It's a very practical book. That's pretty much it. So thanks for listening. Feel free to tweet, email me. The book's online. I've got a few copies. If people want to come up and grab some here, I've got like 10 copies or so, I think. I'll put them on the front. The book's online as well, so you can download an electronic copy if you can't grab a copy here. Thanks to Nginx for sponsoring that one. But I shall say thank you very much.